Hi Bhavna Tiwari, welcome you all in this video. Very first, I would like to welcome you in your new class, that is grade 10th. So today we are going to start a new chapter, the first chapter, that is real number. So look at here, that is real number. Today we are going to start exercise 1.2 as you have already done exercise 1.1 in your class. Okay, so let us start very first quickly with our first question. So what is our first question? Express each number as a product of its prime factors. So हमें prime factors के form में we have to express it. As you knows it properly that how to do prime factorization of these. So in rough we will do prime factorization of 140. So here is rough, you don't have to do in fear. So 2 sevens are 14, 0, then 2, 35 times, 5 sevens are 35 and 7 ones are 7. So what are the prime factors of 140? So we'll write prime factors of 140 are 2 into 2 into 5 into 7. Or we can write it 2 square into 5 into 7. So you can write the prime factorization like this. So one more we can do 3, 8 to 5. Okay. So this is the third part. 3, 8 to 5. So 5 sevens are 35. 3 is left. 5 6 are 30, 2 is left, 5 5 are 25. Then we can do again by 5, 5 ones are 5, 2, 5 5 are 25, 1 is left, 5 3s are 15. Then it will go by 9, 3. Okay, so when we'll add this 5, 6, 7, 8 and 1, 9. So addition is 9, it is divisible by 3. 3 5s are 15, 3 1s are 3. Then 17 3s are 3 1s are 3. So what are the prime factorization of 3, 8 to 5 are 3 into 5 into 5 into 17. So we can write it 3 into 5 square into 17. So these two parts I have done for you. So because these are very easy, you have already done in your previous classes. So I am not explaining it too much. So these are the prime factorization of these two. Two parts are left that you have to do with your own. Okay. So quickly we can start now question number 2. Okay. Now the question number 2 is find the LCM and HCF of the following pairs of integers. So two pairs of integers are given to us. Third part, one part I have not written, part second that you have to do with your own. So and verify the LCM and into HCF is equals to the product of two numbers. Okay. So very first I am telling you this is the formula in your book. What is the formula? LCM into HCF. LCM into HCF is equals to product of two numbers. Okay. Product of two numbers. So which two numbers are given to us? This is the formula you have to write with your own. Okay. So learn this formula. What is the formula? LCM into HCF is equals to product of two numbers. So if two numbers are given to us, if we find the LCM of this and if we find the LCM of them, so what is the product of two numbers? If you multiply them, so multiplication of LCM and HCF is always equals to the product of these two numbers. Okay. The question is find the LCM and HCF of these two integers and verify. Verify karna means verify to prove it that LCM into HCF is equals to the product of two numbers. So my left hand side and right hand side should come equal. Okay. So let us find very first the LCM and HCF. So I am writing 26 and 91 here. Do the prime factorization. So you will do in your rough how you can do 26 factorize it. 2 ones are 2, 2 3s are 6 and 13 ones are 13. Same way we can do the prime factorization of this. So 2 into 13 is coming of this 91, 13, 7s are 91. Okay. So now what is the HCF very first? HCF means highest common factor. Okay. So HCF will be very first what is the HCF? 1. Okay. Then second is what is common in it? 13. So which is common? Factor means it will be always less than the numbers. So this is the HCF. What is LCM? LCM is very first we will take the common one. Then whatever the rest are left we will write them also. That means 2 is left and 7 is left. Okay. So if you will multiply these 7 2s are 26, and then what we will get LCM 182. Okay, so 182 will get the LCM. Then what is there? We have to verify that LCM into HCF is equals to the product of two numbers. So I am doing this part here right now. So LCM verification. Okay, so verification, what is the LCM? LCM into HCF is equals to product of two numbers. Okay, so now what is LCM is coming? 182. What is HCF? 13. Product of two numbers, what are the two numbers? 26 and 91. So multiply them. Okay, 26 and 91. If you multiply these two, so it will come 2366. Same way, multiply these two, 2366, because the left hand side is equals to right hand side. So we will write hence verified. Okay, so this first part is verified. So like this you have to do your question. Whatever is written here, you have to do the same here. Same way we will do the third part, and second part you will do with your own. Okay, so let us start our third part. So your second part is, third part, 336 and 54. Very first you have to find the factors of 336 and 54. Okay, so then we will find the HCF and LCM of these 336. So do in rough. 336, it is divisible by 2, 2 ones are 2, 1 is left, 2 6 are 12, 1 is left, 2 8s are 16, 2 8s are 16, 2 4s are 8, 2 4s are 8, 2 2s are 4, then 3 7s are 21, 7 1s are 7. So what is the prime factorization of 336? 2 into 2 into 2 into 2 4 times, then 3 into 7. Okay, same way we have to do the prime factorization of 54. So it will result 2 2s are 4, 7 times, 3 9s are 27, 3 3s are 9, 3 1s are 3. So we are getting 2 into 3 into 3 into 3. So very first the HCF. What is the HCF? Take common, 1 is 3 and 1 common is 2. Okay, so we get 2 into 3. So HCF will be 6. Same way we can find LCM. I told you whatever is the common we have to write them first. 2 into 3 will write. Then what is left we have to write all. 3 times 2. 1 times 7 and 2 times 3. So we have to multiply these all. When we multiply all these, we will get 3024. Okay, so this will get well multiplying. Now we have to do the verification of these numbers. Okay, so what is their verification? You will write. Write the formula. LCM into HCF is equals to product of two numbers. Okay, product of two numbers. Then very first, what is LCM here? 3024. So in the place of LCM I am writing 3024 into HCF. What is HCF? 6 is equals to product of two numbers. What are the two numbers? 336 into 54. Okay, so multiply these all. So while multiplying you will get 18144. Okay, 18144. If you will multiply these two, you will get this number. Same way if you will multiply these two, you will get the same number. So because the left hand side and right hand side are same, so it gets verified. So you will write, therefore LCM left hand side is equals to right hand side. Then you will write hence verified. Okay, so this is your second question, and one part is left, that is your second part. I told you before also, the second part you have to do with your own, with the same method like this. Okay, so now quickly we can start our third question. Now students, we have to start question number 3. What is question number 3? Find the LCM and HCF of the following integers by applying prime factorization method. So that is same as previous you have done. What is the difference? Difference is there was 2 numbers and here the 3 numbers are given to you. Only difference is this, and there is a lot of difference. You just see here. Same way we will do the prime factorization of 12. Okay, 2 6 are 12, 2 3. Okay, 3 to the 6, 6 to the 12. Then we have to write the prime factorization of 15. Okay, 3 5s are 15. Same way we have to do the prime factorization of 21. 3 7s are 21. What we have to find? LCM and HCF. Very first I am finding HCF. What is HCF? What is the common here? 3 and 3. This is the common. So your HCF is 3. Then we have to find the LCM. I told you for LCM, whatever is the common, you have to take it first and then the rest of the things. The 3 is common here and the rest of the things 2, 2, 5, 7 you have to take. 2 into 2 into 5 into 7. So this is your LCM of first part and it will come 420. Okay. So this is your first part. And simultaneously let us do our third part also. So the third part is giving to you 8, 9 and 25. Okay. Do the prime factorization of this. What is the prime factorization of 8? 2 2s are 4, 4 2s are 8. Then start taking 9, 3 3s are 9. You can do by taking the LCM, factorized type like that, and then you can write 25 and 5 5s are 25. Then what is the HCF? HCF is what is common in all these 3. See what is common? 2 2 2, nothing is common. 3 3, 3 is not here, 3 is not here, 5 is not here, 5. So one more thing is there, 1 is there in everyone. You know that is properly, 1 is the factors of everyone. Okay, so the what is HCF? 1. Same way we can find the LCM. Nothing is common, so we have to take all the numbers. So we'll take 2 into 2 into 2, 2 into 2 into 2 into 3 into 3 into 5 into 5. So 5 5s are 25, 25 to the 50, 50 to the 100, 100 to the 200, and this is 9, 209s are 1800. So the LCM is 1800. Okay, one more part is left that you have to do with your own. Okay, so let us start the next question. So now question number 4 is, given that HCF of 306 and 657 is 9 and LCM, find LCM of 306 and 657. That means these two numbers are given to you. 306 and 657 both are same. HCF is given, you have to find the LCM. So I told you in the beginning one formula, solution will write, and then what is the formula? We know that the LCM into HCF is equals to the product of two numbers. Okay, this you knows. The product of two numbers. So now quickly we will write, we know that. Okay, we know that. Then you write the values in it. What is the LCM? LCM is, you have to find, HCF is given to you 9. What are the product of two numbers? 306 into 657. Now send 9 here. So LCM will this is the numerator, it will go in denominator. 306 into 657, this side we will write as it is, and 9 is in multiplication, here we will send, it will come in division. Now this is multiply, cancel it. 9 3s are 27, 3 is left, 9 4s are 36. So 34 into 657 you will get is 22338. So your LCM will come 22338. Okay. So this is a question. You have to find the LCM and the method is LCM into HCF is equals to product of two numbers. Very easy. So let us start the next question. So now the fifth question is, check whether 6 raised to the power n and can end with digit 0 for any natural number n. क्या 6 raised to the power 0 से end हो सकता है? Can end with digit 0. That means अगर 6 raised to the power n, you just substitute n is equals to 1. n कोई natural number है. So 6 n is equals to 1, तो 6 raised to the power 1. 6 1 is 6. n is equals to 2. 6 into 6, 6 6 is 36. It will end with digit 6. So every time when you substitute 1, 2, 3, 4, any time it will not end with digit 0. But how to write it? For end with digit 0, it should have a prime factorization of 2 and 5. जब 2 और 5 होंगे तभी वो 0 से होगा, end होगा, otherwise it will never end with digit 0. That means alone 2 will be there, it will never end with digit 0. Alone 5 will be there, it will never end. Both should be there, 2 and 5. Okay, so how will write? We will write solution. We have to check 6 raised to the power. How we can write 6? We can write 2 3s are 6 whole raised to the power n. Again, if we will just open it, we can write 2 raised to the power n into 3 raised to the power n. So you can see here 2 and 5 should be there. Okay, then it will end with digit 0. If 2 and 5 both are not there, it will not end with digit 0. Okay, so what you will write? By uniqueness of this, I told you in the class, uniqueness of fundamental theorem of arithmetic, fundamental theorem of arithmetic, it has the fixed prime number. Okay, the prime factorization are unique. Okay, by the uniqueness of fundamental theorem of arithmetic, the prime factorization of 6 raised to the power n are 2 into 3. ठीक है, 2 raised to the power n, 3 raised to the power n, that is unique. ठीक है, तो ये यूनिक होंगे. It has no factors as 2 raised to the power n into 5 raised to the power n. Therefore, it will not end with digit 0. Okay, with digit 0. Okay. And I told you previously also, this is very important question. Okay, so do it properly. So this was your question number 5. If you want to see it again, revise the video, see it again. Okay, so now we'll start the next. Now the question number 6 is, explain why 7 into 11 into 13 plus 13 and the second number 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. हमें करना है कि explain why these two are composite number. ये दोनों composite number क्यों हैं? We have to explain this. And what are composite numbers? I told you previously also. Composite numbers, we have two numbers, prime numbers and composite numbers. ठीक है, prime numbers and composite numbers. So these are the pair of prime number and composite number, and there is different pair of even number and odd number. So these are different. Even and odd are different, prime and composite are different. Even and odd, that means which is divisible by 2 and which are not divisible by 2, they are odd, and which are divisible by 2, they are even. This is different group. And different group is prime and composite number. Prime numbers means which has a factor 1 and itself. Okay? If we are saying of 3, so it has a prime factorization 1 and 3. So that means how many factors it has? 2 factors, 1 and 3. Okay? Over these, what are the prime numbers? Which has 2 factors, that means 1 and itself. Those are known as prime factors. And the composite numbers different, which have more than 2 factors. That means if you take 4, 4 is 1, so 1 is already there, 2 into 2. So how many factors it has? 1, 2, 3. So it has more than 2 factors. It is divisible by 1 also, it is divisible by 2 also, it can be divisible by 4 also. So it has more than 2 factors, that means it is composite numbers. And the question comes, what is the smallest composite number? So that time your answer what should be? The smallest composite number is 4, because if we take 2 if we take, so what are the factors of 2? 1 into 2, again it is a prime number, 2 is a prime number, and 1 we will never take. So okay, 1 is 1. So starting with 2 prime, then the smallest composite number is 4. Please remember this. तो अब composite number क्या है कि they are saying explain that this is composite number, ये composite number है. अब composite number means it should have a prime factorization, बीच में सिर्फ multiply होना चाहिए, but here plus is also there. ठीक है, so we have to solve this first. So this is the first number I have written here. How you can solve it? See how many terms are there. This is the first term and there's plus sign. This is the second term, so we can take common. So 13 is in this term also, in this term also. Take 13 common. So what is left inside? 7 into 11 here, okay, and plus 1. So now solve it. 13 into what is 11 7 is 77 and 1 78. If you can solve it, it can have more factors. So that means it has 1 30. 2 से divide करेंगे 2 2 3 is 6 1. So more it can be, तो 3 से और हो जाएगा. There are more factors. So we'll write as it has more than. Now there is no plus sign in between. See, all are in form of multiplication. ठीक है. So now we have done factorization. So it has more than 2 factors. Therefore, it is composite number. Okay. So like this you have to write. Therefore, it is a composite number. Similarly, we have to do the second part. So let us do the second part also. Now the sixth question. Explain the second part I told you. The previous one I told you. Then the second part. There are 2 terms. One term is this and one term is this. What should be common? 5 is here also. 5 is here also. Take 5 common. So what is left inside? 7 into 6 into 4 into 3 into 2 into 1 plus 1. So now solve it. 5. Okay. So we can do 3 2 is 6, 6 4 is 24, 24, 6 7 is 42. 42 into 24 we can do. Okay. 4 2 is 8, 4 4 is 16 and 2 2 is 4. 20 carry over 2, 4 2 is 8, 9 10. Okay, 1008 plus 1. If we'll do 1 into 1009, and if you just multiply this, 5 9s are 45, carry over 4. Okay, so now if it's 1045, it will come. Then if you just do the factors of this, it will come 5 into 11 into 90. So if you solve it, you will get the factors of this. Okay, so now. So same way you will write here as you have done in previous one, but you will write solve yourself. Okay, I told you the method, you have to solve yourself. Now do yourself. At the last what you will write, as it has more than 2 prime factorizations, therefore it is a composite numbers. Okay, let us do 7th question now. Now the students, the question number 7 is what is given to you in the book. See, there is a circular path around a sports field. तो sports field है and the circular path is there. ठीक है, ये sports का field है circular and there is a path, circular path. यहाँ से they runs. ठीक है. So what they are saying, Sonia takes 18 minutes to drive 1 round. If Sonia starts from here, 1 round she takes in, Sonia takes in 18 minutes. Okay, 1 round. Then what they are saying, while Ravi takes 12 minutes for the same. So Ravi also starts and Ravi takes 12 minutes. Okay, Ravi takes the less time. Okay, taking 1 round. Suppose they both start at the same point. They both start from the same point and thus at the same time and go in the same direction, and they are going in the same direction. After how many minutes they meet again at the starting points? Okay. So after how many minutes they meet again? तो कितने मिनट बाद वो फिर से मिलेंगे? So definitely है कि अगर 12 मिनट्स में करता है, 18 मिनट्स में जाता है, तो ज़्यादा ही मिनट्स में मिलेंगे, कम मिनट्स में तो नहीं मिलेंगे. इनसे तो ज़्यादा 12 और 18 मिनट्स से तो more time में they will meet. So that means you have to find the LCM. Okay. So they will meet again. So Sonia and Ravi. will meet again in time will be the LCM of, okay, will be the LCM of 18 and 12. ठीक है, तो जिस टाइम में मिलेंगे that will be the LCM of 18 and 12. Now you can find the LCM. Do the factorization of 18. 2 9s are 18, so 3 3s are 9. These are the factors. 12, 2 6s are 2 3s are. ठीक है, these are the factorization of 18 and 12. Now we have to find the LCM. So therefore LCM equals to, first take what are common. These two are common. So 2 into 3. Then what are left? You have to write 2 into 3. Okay. 3 3s are 9, 9 2s are 18, 18 2s are 36 minutes. So they will meet again in 36 minutes. They will meet again in 36 minutes. Okay. So this was the 7th question of exercise 1.2, which was the last question of this exercise. So hope these questions are clear to you. If you have any confusion, please revise the video and see it again. But you have to do it definitely, and you have to do it in your classwork notebook. Okay. So for this video, this is enough. Next exercise we'll do in next video, and you have to do the examples of the same video in the notebooks. Okay, so don't forget to do your examples. Till then, keep watching the video. Please do subscribe and like the video, and till then, thank you very much. Bye bye.